He is a malware engineer at iSight Partners, focusing on the analysis and characteristics of malicious code, and is also the executive director at Spectre Labs, which specializes in digital forensic and data recovery services. He's got over 20 years in the information technology field. Shane is a frequent speaker in industry events and teaches security courses at the University of South Florida. He holds a master's degree in digital forensics from the University of Central Florida and is also the co-author of the book Android Malware and Analysis. So with no further ado, it'd be my pleasure to introduce to you Mr. Shane Hartman.
Thank you. All right, I'm not good at working with mics, so I'm going to do the best I can with this. And I'll do the best I can with it. Anyways, thanks for the introduction. I appreciate that. Glad you guys came out to BSides, something a little bit different. Thought I'd go ahead and present some of the work that I've been doing over the last couple of years. The company I work for, specifically is Spectre Labs. We do digital forensics and analysis, but I also work for another company called iSight Partners. I specifically do Malcode analysis there. And nobody was doing mobile, but it was starting to come on the forefront. We were seeing more and more mobile type requests and people wanting to know, what is this Android stuff? Is there something, is it validity? Am I protected? What's the deal? So I took it upon myself with another coworker to actually put together a analysis ability within our company to do that. And what you're seeing here is part of that evolution, if you will, on how to be able to do this, and I'm sharing that with you guys today. In addition to while we were working on that, we decided to put together what tools and features that we thought worked the best, and we ended up publishing a book on it called Android Malware and Analysis, which I'm a co-author of and wrote mostly on the being able to do the physical analysis of devices within the network. Let's get into some statistics. All right, Android has been around for a little bit while, and now it says that about 97% of the U.S. consumers have at least 3 wireless devices either in their house or on their person. Either your cell phone, tablets, and it continues to expand. How many of you have heard about the TV, the Samsung, that's now reporting what you're watching? Brand new. I mean, it continues to expand. We're going to have 3, 4, 5. You need to know what these things are doing on your network, personal or otherwise, and it will continue to expand from that point forward. In addition, mobile malware is a ever-expanding area because we're doing more and more stuff on our phones, tablets and whatnot, and we're doing less and less on our computers because you always have your phone with you. How many of you guys actually use Twitter from your desktop? I mean, seriously. Oh, okay, I got one. How many use it from their phones? Most people use it from their phones. Those are the type of things that I'm talking about. You use it more and more stuff like that. Banking apps, the ability to house your contacts, your phone conversations, your text messages. Everything is on your phone. It becomes an extension of what you are. And because of that, it makes it a huge target-rich environment. One of the other things that's interesting about this is the infrastructure and the way it works is in our traditional types of setups, we have Ethernet cables and networking, and we're able to easily trace what's going on between it. We can put taps in, we can capture packets. A lot of this stuff goes over the cellular network, and if you don't have any way to capture that cellular traffic, you don't really know what's going on your phone. Another thing is that, especially with Android, is it's open source. Because it's open source, we can look at it, see the security flaws in it, and exploit those flaws as we see fit. That is a benefit and a curse of open source, so you just have to take it with you. Also with Android there's a lack of granularity when it comes to applying rights. When you as a developer are trying to ask to do one specific thing, you tend to have to ask for more of the pie than actually just the piece. And because of that, it has been more able to be exploited as a means to an end. So if I ask to be able to write to the file, just to write a file to the system, you don't just get to that file system, you get rights to like the whole directory kind of things. That's what we're talking about. Then we also have some loose security within the App Store. When you submit stuff to the App Store, that's usually where they would suggest that you go to get your apps, and most people do. But they don't actually review those really, really well. How many of you have ever heard of Bouncer, the thing that came out from Google that was supposed to put on the Play Store? You submit an app to it, it'll tell you whether or not it's good or bad and move it through. They found out it didn't really work very well, and they're not vetting it. And because of those type of things, things have allowed themselves to get through. Conversely, on like the iPhone, which I'll segue here for a second, the iPhone, they actually analyze and take a look at each app that's submitted. That's why we see so little malware for Android phones in comparison to the Android applications. That's my only spiel on iPhone for right now. I happen to own an iPhone for that one reason. But let's go ahead and keep going on to the Android markets and such. Android themselves, there are a lot of different Malcode types that are out there. Everything from, and part of these is a lineage that you would see similar to what you would on a regular Windows type machines. The only thing is it's accelerated like tenfold. What occurred in the malware space for Windows from like the early 90s to say 2010 has been condensed into about 4 years with the Android market. We started out with things like phone cloning, just copying a phone, using it somewhere else, not having to pay for any charges. Then we moved into things like premium SMS and adware that are actually starting to either cost you money. Then we have something, I call it scab apps. Doesn't seem to be an industry term for it. It's where they take an application that you would normally pay for. Let's use Angry Birds for an example. You don't want to pay for it. You want a free version. So you start Googling or trying to find out, where can I get a free version of Angry Birds? Bingo. You'll find one. It only takes a couple of minutes. What happens there is they've taken a purchased app, they've downloaded it, decompiled it, which I'll show you how to do here in a little bit, put their own code back in there, compiled it back up for you to be able to download and run on your machine. You can play Angry Birds all day long for free. The only problem is it's not going to cost you $4.99. It's going to cost you all your contacts and whatever else that you might have on your phone. That's what I call a scab app. They scab their code onto the app that you wanted to use. But like I say, there might be another term for it. I haven't encountered one yet. Remote access Trojans. These things are what are starting to see emerging. Being able to get into your phone and actually leverage it as a pivot point against something else. Financial fraud in the form of token generators. Anybody ever heard of Zitmo or Spitmo? Anybody heard of Zeus or SpyEye? This is the mobile versions of those. The other thing we have is botnets, and something that has shown up relatively recently on our radar a lot is CryptoLocker and SimLocker and those type of things, which I'll show you here in a little bit. Now, Android itself has been through a lot of different revisions over the last few years. In fact, this is how many different versions of Android that are out there. There are quite a bit of different phones, quite a bit of different devices that are able to be used. A couple of them aren't that popular, like Honeycomb. I don't think it lasted very long before it went to the next one. This versioning list is always available up on Google. You can find it in their application developers suite. Now, looking at that, this is what the distribution of those SDKs look like. Up at the top with Froyo and Gingerbread, which are some of the oldest ones that were actually working, they're very little market penetration. However, Jelly Bean and Kit Kat represent most of the market. So if I'm a malicious actor or whatever, I'm going to be looking at where I can get the highest concentration for the biggest buck. And these are going to be the areas that I'm going to look for. Lollipop's just too new. It'll eventually convert over. I just don't know how long they take. The conversion process has a twofold mechanism that I see. It has to do with when it's released to market and when all your cell phone contracts are up. And then that will actually move that market accordingly. So what actually is an Android application? Anybody ever actually looked at one and seen what it is? I mean, we know what executables are and zip files and config.ini. We can look at them. Android applications they end with an APK extension, and they're basically just a zip file. They contain a package, and inside of it, this is, if you were to unzip it or rename it to zip it, unzip it, this is probably what you'd see. Directory called metainf and another directory called lib, and then you'd see a res directory which contains resources. Then you see a couple other files, the Android manifest.xml. It's a very important file. You can't read it by default if you just unzip it. It looks like a bunch of goop on your screen. Classes.dex. This is the file that actually contains all of your Java class codes inside of it. Again, you can't really read it too well. And then the last one there is resources. when you're developing an Android application, it's normally developed in Java, and then it's compiled twice. First it's compiled into Java bytecode, then it's compiled into Dalvik, I think it's, or Dalvik. That's where this ends up coming out to that. So in order for you to be able to actually read it, you have to go through another double compile in order to get your files out of there. But there's apps that'll actually do that for you. So now that you know a little bit about Android applications, how they're built and how they're put together, how do they get on your phones? Here's a couple different ways. Social engineering, which is what I was just talking about. You're looking for an app that you don't want to pay for, and you're willing to actually compromise your device in order to get it to it. Compromise ad services. Some of those apps that are legitimate and free, in order for them to generate revenue, they provide ad services. So you'll see when you get past level 8 and kill the boss, you see a little ad flash up as you go to the next level, or as you move those ad services are spawned to your machine automatically. And they are not in control of the app developer, they're in control of the ad service that they're using. If that is compromised in any way, shape, or form, then your phone can be compromised as well. I touched briefly on the Play Store itself. If an application gets in there, then that would be another way that you get it. The last one, there's PC infection. And this one speaks specifically to the financial fraud. If you've dealt with Zitmo or Spitmo, which are the two, SpyEye in the middle and Zeus in the middle, part of the way it works is your PC gets infected, and you go out to your bank, and you go to get ready to do transactions, and a message pops up on your screen through a web inject. And the web inject says, hey, we're increasing security on our networks and stuff like that. Download our mobile app in order to be able to help further secure your device. And when you do that process, this is it. You get the next piece of it, which is either, like I said, Zeus or SpyEye. And then at that point, if you do any financial transactions from your phone, those are also compromised as well. We good? All right. Now let's start to get into some of the deep stuff. Static tools analysis. So you've got an APK. What do you do with it? All right. On the static side, there's a bunch of different tools there's more tools than I can explain within the hour. I just don't have enough time to do that. But some good ones that are here are things like AndroGuard, which helps do decompiling, Dex2Jar, JDGUI, DexID, Dare, and apktool. I starred a few of them. Those are the ones I use the most. The first one, like Dex2Jar, will convert classes to the Dex, and then you can use, from there you can open up the jar file and look at it. JDGUI actually opens it up so that you can look at the jar and look at the classes. And the APK tool does a compile and decompile, which actually is right here on the next screen. This is kind of what it looks like. This is, what you're seeing there is a jar file after it's been pulled out of the classes.dext. And now I can go through and you can see right there at the top, you can see the actual com directory that it has, you can see the classes that are underneath it, and you can see the pieces that go together with it, and you can read the code. It's not perfect, but it does do a fairly decent job. There are some other apps that can do this probably better, but they're commercial, and if you don't want to pay for them, then you don't want to pay for them. That takes us to the APK tool. The APK tool, which is another very useful tool that we use a lot, can decompile and recompile APKs. In addition to being able to do that, this is the application that uses to convert the Android manifest.xml into something that's legible. So you can see what rights are being asked for, what classes are starting up by default, if it's going to use services, all kinds of pieces that you can find out in there. In addition, there's another file that it will produce, which I'll show you here in a couple minutes, that will show you the minimum and maximum SDK that it's using. The reason why that's important is if you're doing testing like I do where you have different devices, that it might not work on one specific device, but it'll work on another because it's within that SDK format that it's looking for. In addition to that, you can also just like what I talked about with the scab apps, you can go in there and change certain parts of the application, recompile it, and run it again on your machine. By doing that, sometimes you can hijack, say, a CNC, or you can change what directory a file is going to write to. You can do some of that. You have to go through the code and actually do it. I'm not going to go into that much detail, but it is available for you to be able to do. So this is on the static side. On the behavioral side, we have a whole bunch of different other types of tools. We use Eclipse, which Eclipse is a development environment for actually applications in general, but they have a plugin for developing Android applications. It also has a debugger that you can, if you're developing apps, you can use it, but you can also use it as a tracing utility. In addition, the SDK that you load down from Google has an emulator in it. And the emulator itself will actually, you can emulate any phone that you want. Then we have physical devices like phones and tablets that you can use. And we have a couple other things here called fake DNS, which we use in order to fake out the DNS that's going, so it doesn't go to a remote DNS. It just says everything that you do, a request from a domain, it comes here. And then you can actually capture any of that traffic that's going there. Web server. Most of these things are going to use web services of some form. So you set up an Apache website and then you just let it go to it. I'll show you all this in just a moment. And then we got Wireshark, which most of you should know is a packet capturing utility. So now let's look at the first thing. What an emulator looks like. It's also called an AVD, which is short for Android Virtual Device. And this is just a setup of one of those. You go through the SDK, and then you say, I want to create a new one, and it says, okay, what kind do you want? Do you want KitKat? Do you want Froyo? Do you want this? Just pick out any one you want, and then give it some parameters and hit start. As soon as you start, a few minutes later, what looks like an Android device will show up on your screen, and you can interact with it as much as you want through something called the ADB, which is the Android Debug Bridge. Again, I'll talk about that here in just a minute. When you're using an emulator, one of the things that it does, I know it's a little bit of a bright slide, but what it does is it actually shunts off the network card that's on your machine in order for it to be able to do its networking activities. So anything that you do from the emulator will show up as your IP address on your network. So be aware of that. If you're going to run an emulator and you're going to run malicious code on it, make sure whatever the platform that you're running underneath it is also like a VM or something that you've got it protected, because it's not protected by itself. Other ways that I have run it, which you can see here, VM to VM, also have physical VM to two interfaces. If you play around with the networking enough, you can figure out different configurations by which you can make it work. Again, I'll describe actually the physical setup that I did here in next slide. All right, the physical setup that I have here is more like what I have kind of in my lab. I have a lab machine that's all by itself. It's not connected to the network at all. However, it is connected via USB to that machine. The reason why that is so that I can push code to it and I can also debug it at the same time. So I can trace it, what's going out. Now it connects, just like this one, these two devices that I have here, they're connected via USB to this laptop, and they're wirelessly connected to this wireless access point, which goes nowhere. It does absolutely nowhere. Then what I have is I have another virtual machine that's sitting on another device that I usually have hooked up, and from there I'm able to proxy that connection through an unattributable VPN so that whoever I'm connecting to on the outside world doesn't know who I am. And that way I can see what CNCs are, I can see what's going on as far as that. This is a kind of a dummied version of it in which I took the outbound connection and plugged it back into the network interface card in this, just so that I could capture traffic. It's a shorter way to make it work, but it does work in that instance. Now, if you want to get apps on and off a machine, and you don't want to use the ADB, you can use applications that are within the Google Store, such as the App Backup and Restore. I use this a lot, especially when I get requests going, hey, we think there's something on the Play Store that might be malicious. Can you download it and look at it? You can't go to the Play Store and just click download. It doesn't let you do that. You don't have a mechanism by which to do that. You have to go through the actual Play Store app or through your web page and do the Play Store. But I don't have my account registered through the Play Store to my dummy device. So at that point, what I do is I have an actual Google dummy account that I use against this, let it go out through the proxy, and pull that actual APK down. Then I use Backup and Restore to actually copy it off to a physical SD card so I have it. Then I can play with it as much as I want, because up until that point, it's just on the device. Other ways you can do it, like I said, is with the ADB bridge. You can push and pull them that way if you want to do that. It's a lot harder. It's more command line stuff. If you want to do it that way, feel free. I like that backup and store. It works pretty good. If you're going to purchase physical devices, it's just a thing that I encountered relatively quickly when I bought this tablet, which was one of the first ones. If you get a device, make sure that you have a physical SD card, because like the Nexus 7 here, what it does is it makes a virtual SD card. This device is closed, so I can't actually physically get to it. If I have any code or anything that writes to that physical SD or the SD card, I can remove it. And when I can remove it, it means I can put it in another machine and do a forensic analysis on it. I can do any number of things with it because it's a physical device. I can remove it. I can't take the chip out of the Nexus 7 in order to be able to do that. So if you're just purchasing one, think about having an actual physical SD card entry that you can have in there. Make sense? Cool. All right. Let's talk about a couple samples. Some stuff that's recent, some not so recent or whatever. Everybody heard about this? Yeah, the interview. How many of you know about the Sony breach? And anybody doesn't raise their hand, they haven't been reading the news anytime recently. Shortly after the Sony breach, an Android application came out that said, hey, do you want to watch the interview? Remember when they said they were going to not show it, you could release it? We found this application out there, and what it turns out is that it was a Trojanized version of this app, and it's just a financial fraud banking Trojan. So what it does is when you click on it, it goes out to another website, downloads another APK and installs it, and it looks like a Korean bank. And then there you can see actually this is the URL that it goes to, and then it does this get for another APK and does an install for you. That's all that it really does. So it was just a trick. It social engineered you enough to say, hey, you want to watch the interview? And here you go, you got it in. A lot of the applications work that way. So actually, while we're here, let's do a little bit of a break for a second. See if I can minimize this. If I can get out of here. Alt-1. Let's take a look at it for a second. All right. Let's look at a physical thing here for a second. I brought one of my virtual machines with me. And if demos work correctly. All right, this is the virtual setup that we helped develop when we were putting all this together. We call it A3 for the Android application analysis. It pretty much has all the tools that I've been talking about in one place in a virtual machine. I will make this available on my website later on tonight. I just didn't have a chance to copy it before I left. What we do here is this has all those tools that are in there. And speaking of which, if we go right here into our samples, we have, let's see, the interview. Oops, let me go back one. If I could get there. A samples. Actually, we called it Korea at first because we didn't know what it was. Copy. And you see how I had it as a zip? That was just because we were doing some analysis with it. Paste and rename it. Forgot to do this beforehand. .apk. All right. You see we've got a directory here called code. What we do is we drop that APK into this folder called code. And then we run the static shell. And all that does is just runs a whole bunch of our commands. It decompiles it, it runs text to jar, it does all this stuff for us. And we run it, and this is really usually pretty quick. So you can see there, it starts the analysis, and it's pulling stuff. It's getting MD5s, it's creating its AndroGuard, and then it's going further on and creating a temp APK and some other stuff, and it's pulling out all this stuff that's in there. And in a second, we'll be able to look at this statically about all the different components that were put in here. And see, it's relatively quick. Depends on how much stuff's in it, but the more stuff in it, obviously, the slower it goes. Then what we got is we get a folder here, and inside of it you can see we've created a whole bunch of stuff. apktool. I don't want to send anything anywhere. That's what happens when you're trying to hold a mic. Primarily what we look for when we first open this up is we look at cert.txt because we'd like to know who is doing the app, which some of these are traceable. See, in this particular case, the email address is android@android.com, but it's got an MD5 signature in it. And the reason why that's important is because if we are tracking somebody that's continuously doing something, that MD5 will show up many, many times, and we'll be able to go, this is attributable to this person. We have no idea who it is, but we know it's within the same family because it's the same key that they're using. In addition to that, which we go from there, we'll go into the APK tool. Now this is when the APK tool just decompiled this, that's all that it's done. Let's look at this first one, the APK tool YML. What's cool about this is here's what it tells you. It'll give you versions, it'll tell you what the minimum SDK is and the target SDK. Those are the things I was saying is important about what devices you have, because then you know what you can get it to. The next thing is, from there, we go into the Android manifest. And what's cool about this thing is this tells me everything. This one's not as good. I'll show you another one that's better in a minute. This one tells me what the default package name is, which is com movie show down. You can see a little bit further what permissions it's going to ask for. It's going to ask for internet permission, write external storage, and install package. So this is what rights it's asking for the ability to go out, pull that file down, and install it on your machine for you. So this one isn't super huge cool, but it is definitely there. Now, I'm not really going to worry about that, but what I'm going to do is I'm going to go into this. This is the actual downloaded one. I went ahead and decompiled it before you guys got here. Now let's take a look at it real quick. I know you guys probably won't remember, but see, we've got more MD5s. I did not check that before, but look, the owner and issuer are different. So this is obviously something else going on. But we could still trace it. We keep an eye on this kind of stuff in case they show up again. So again, we've opened up the cert. We go back into the APK tool, do the exact same thing. Do you see where the pattern starts to come along? Open up the APK tool. This one asks for a lot more stuff, including, look, Java Mail, some other DNS stuff, some other stuff that's in here. It makes it very, very interesting going, oh, this must be asking for some extra stuff. And then again, your minimum SDK and target SDK. Anybody notice anything different? It's not the same as what the other one was. Meaning that this Trojan was designed to have a wider group of people than what the first one was. The significance of that, only in the sense that when we actually looked at when these came out, this came out first, and they used the interview methodology as a segue to get that on there. It had nothing to do with anything. They just developed it ad hoc real quick. Go download this and install it. We want the baking Trojan. That was what they were worried about. So now, let's go from there. Let's go see what the manifest of this thing looks like, which I would suggest, think it was a little bit bigger. Yeah. Okay, this thing's going to read SMS messages. It's going to read your contacts. It's going to get internet, external storage, read phone state, receive boot completed, all kinds of stuff. This is all the rights that it's asking for on this device that you basically gave it. In addition, if you start to go down, there is even more stuff. And whoops, let's see if I can scroll that a little bit. When you divide these up, the first part of these usually asks for what permissions that the application wants. And then we get into these other things called activities, intents, receivers, and all that kind of stuff. What those really are they are when it wants to fire code. If you push a button, if you turn off the device, if you turn on the device. And then usually what these tell you is what code that it's going to run. Like this one right here, the Android receiver name, com.aa systemr. We can open that up and see when it is. And its intent is when boot completed, action shutdown, and user preset. I'm not sure what that one does. That's when that fires. And then you can continue to back those down. There's a whole bunch of them in here. There's more than I can actually go over at this point. But you can kind of see how this application is going to work. But I haven't talked anything about any of this other stuff. Let's talk about those. All right. The small e directory, or small I, whatever you want to do. What this is the BALAC code. If you want to go in here and mess with this, you have to use the APK tool to recompile it. I'm not going to go in there because it's not really that legible. Assets. Assets are where extra items are put in there, like the picture that you see, like GIFs, JPEGs, and stuff like that. Also sometimes config files. Libraries is another place where you will see stuff. This one, if you notice, it's actually when they were doing the designing, this application has multiple stuff in it for different types of devices. MIPS device, x86, and the Android devices. let's see here, resources. Resources, again, are the same type of things. If we go in, whoops, let me see if I can find the, oh, those are just, I'm trying to find values. Another one that you want to go into a lot is called the values directory under resources. This strings file is a lot of text that will show up on screens. So what you want to do is open this up and take a look at it, and sometimes you can find details in here about the application as well. This one you're not going to be able to do too much because it's in Korean. But you get an idea, if you were looking at this, you could obviously translate it, what your target audience is. The other thing, in some of these resources, you'll find directories that will say .ru, .cn, .ch. If you've done that, it means the application was developed for multiple language purposes and so that it will run on multiple platforms. That is a lot of kind of how the static side works. There's more details that are in there, but I also want to show you a little bit about what the physical side looks like. So first thing we're going to do is we're going to show Eclipse here for a second. When we start Eclipse, and we have the SDK and tools installed, there's a DDMS, which is the debug messages for Android. And you can see there at the corner I have two devices. Notice one of them has really not a whole lot of stuff on it, and the other one does. The reason is because one device, which is the small phone here, is actually jailbroken. And when it's broken, it means that it doesn't really care as much about the writes. I can see completely into the device. Any app I want to look at, I can actually debug and trace. If I don't have that and I have a non-traditional device, such as the tablet here, you can see I can't really see much into it. The only thing I'd be able to debug against that is if code on there is actually set in debuggable mode, which you can reset into debuggable mode with the APK tool. I'm not going to go into that because it takes too long to actually do it with writing certificates. But you can see here's all the apps that are, all the things that are actually running in it. Now down at the lower half of this is what's called logcat, and what that's doing is it's logging, it will log or show you any classes and things that are being called on any particular thing that you're working on. And you can see, if I can get it to scroll a little bit, I don't have as much real estate, you can start to see some of the processes that are running. Now also, you notice when I clicked on that, I was able to open the File Explorer is open. Over here, I can actually explore the file system itself. The reason I can do that is because this is a jailbroken phone. So I can actually explore down into the phone. You can do it somewhat here, but it is limiting, and it, like this one, tends not to show up. So that's this piece of it for you to be able to do debugging itself. In order for you to be able to actually debug or look at stuff, let's look at, there's a couple different ways. Can you guys, oh yeah, you guys can see that quite well. On newer devices, you have to go into, let me see if I can find settings here real quick. You have to go into settings, and if it's a brand new device, brand new meaning, you have to go into the About tablet, and you have to go down to down here to, once it flips over, to build number. By default, the debugger tools are not available on newer devices. They just have them locked out. I don't know why they did that. It seems ridiculous that they did. Anyways, when you can't get to the developer's tools. In order to do that, you have to press this like 7 times. And if you do it 7 times, eventually you'll see you no need to do it. You're already a developer. It'll say it's unlocked and now developer tools are available on your device. What that means is, when the screen flips here, this little that developer's options will show up. Until then, you will not see it. And then when you go in there, you can set up all the developer options that you want. This is what you need in order to be able to do some of the debugging. And you turn on USB debugging, and that's how this device is able to be seen. A couple other things that are interesting in the newer devices is, which I turn on and off all the time, is, let's see, turn off verify apps over USB. The reason why I particularly turn that off is because I'm working with a malicious app and it will probably try to stop it. But that is one of Google's ways of trying to help keep apps off your machine, is by verifying apps. And it'll say, hey, this might not be a good idea. So this is kind of what you need to be able to do that. Now, once you've got all this stuff kind of set up, and you can kind of take a look at it, let's look at an actual app and see what it does. Let me wait to that screen. All right, I've got a couple apps that are in here that are already there. First thing I'm going to do is fire up fake DNS, which is something that I talked about right now. Let me put the Android A3. Okay, now what this is doing is it's taking the interface that's on here and it's looping it back. So it says, any DNS request to this, just send them here. I'll take care of it. There's a web server that's already running in the background. So let's go also open up a terminal real quick, and let's fire up Wireshark real quick. Am I over time? Okay. All right. Almost done. All right. We're going to just capture options and Ethernet. Start. All right. And we're going to change this real quick. Sorry. 1, 2, 16. What I'm doing right now is I'm setting my capture filter to be the external interface on this, because that's where all my outbound traffic is coming out of my wireless point. So right now you see that there's not really much going on. And then at the top, you see the actual requests that are going through there. So something, oh, I actually already fired it off. So let me see if I can flip this real quick. Okay, so you got that going. Let's fire off the actual interview. Let's see if we can get it to actually do what it wants to do. So right at the very, very top, it's really kind of hard to see, but there's the actual launcher right there. So this doesn't do anything just quite yet. But as soon as I press that, if everything works real good, I should get a request. There's the request to FCLI, which is what I was talking about before. That's the actual request to go download that file. And then we can also see right in here in the PCAP, we can see in the the stream right there, there's the items and get the APK, and this is what's going on. And at this point, I don't have that actually set up so that you can find it, but if it were, it would download the banking app and install it for me. Kind of cool. Some different stuff. So let's see if we can find another one. Let's close. There was a problem with that. Yep, there's definitely a problem with the package. Okay. Let's look at this one. There's an app there. See that Adobe Flash Player? Adobe Flash Player, this was one that came over over the summer. I worked extensively on this. There's a whole family of these that came out. When you were going out to the internet and you were surfing around, this message would pop up and say, hey, your Flash Player is out of date. Do you want to update it? And if you did, this is what you would get. You get this application. So kind of everybody want to see. Oops. It that way. So go ahead and click it. Let's see if that one fires. There's the we see a request that's going out. See it's starting to run, and it says, action required. This is a system application. You must activate your device administrator. All right, let's go ahead and activate my device administrator. And it'll take a second and see what happens here. Oh, things aren't working. I don't know. It's thinking. Please wait. It's grabbing some stuff. I don't know what it's doing. Not really seeing much activity there either. Let's think. Give it a second. It'll get there. Usually took a little bit less time than that. Come on. It's the last one I show you, I promise. Come on. Almost ready. A couple people probably already know where this is going. But I'm just waiting for it to finish. It takes a little bit different times. But the app is actually, at this point, what it's trying to do is it's trying to lock your phone down. And if it works the way it's supposed to, it should display a message here in just a minute whenever it finishes figuring out what's going on. I've got it on both machines. All right, come on. All right, I'll let it sit there for a second. What actually happens is this particular app, it's called SVPeng. It was one I worked extensively on over the summer. What it does is when you're surfing the net, you're not just surfing specifically the net. You're surfing porn with your device. And what happened was it said, hey, your Flash Player's out of date. And that's where the FBI piece comes in. And it displays a message that'll be on your screen that says, hey, you've been surfing porn on your device. and that we're reporting you to the FBI, and it activates your camera and takes a picture of it and says, we have gathered your information for evidence. And that's what you see. That's not a real actual URL that it's going to, but it's locked your device down, and then it asks you to pay via MoneyPal or something like that, some arbitrary amount. It changes each time we actually get one of those. Doesn't look like it's going to finish. Maybe, let me try restarting it. Anyways, once it's done with that, your device is completely locked until you either pay the ransom or you give up your device. It actually took me about 2 days to figure out how to get my device unlocked, and it required an actual push of a complete image back down to the machine in order to get it to come back up. Because when it asked for that specific privilege, which I'd never seen before, it was like beyond root. It was so deep into the system that I couldn't get it, I couldn't undo it. And that was what ended up happening when I stayed locked down. I don't know if it'll switch or not. But I tried to give you a whole big overview of a bunch of different stuff. It's bigger than what I can just explain in 45 minutes to an hour. So what I'm going to do is I'm going to go ahead and show you a couple more slides and open up for questions. Just 1 second. And in addition to that, I got a couple more slides to show. Oops, Alt-2. Just some online resources and stuff. These were, let me see that. XDA developers. These are just some of the places where you can get some of these things. If you want to work with malicious APKs, these are online sandboxes. If you have an APK that you want to send up and you want to have it analyzed, you can send them to these ones here. Up at the top are the XDA developers and Google code so that you can unlock phones. You can figure out how to ROM your phone, do all the different types of stuff like that. I'll make a brief note about Android antivirus. It pretty much is non-existent. The reason is because it uses signature bases to do that, and the processor is so limited because it uses so low power that it can't do heuristics or anything like that. So it's relying completely on signatures. And because of that, that's a limitation in its own right. It's better than nothing, but it's still. I'm sorry? Say, UCount? Oh, Lookout? All of them are kind of the same. The inherent problem that comes with it is the processor. They're designed, the Android platform is designed to be power conservative. In order for you to do really heuristic and antivirus and good antivirus stuff, you have to actually scan the machine all the time what's going on. They'll burn the battery out. We don't have the battery capacity to be able to do that. I'll get to your question in just 1 second. Future attacks are going to continue. Exploitation will be less on what I think the phone itself, and contacts and stuff will always be there, but I think we're going to be moving towards a place where they're going to actually leverage your phone as a pivot point against something else. My research that I'm going to take into the summer is going to be on NFC for near field communications and payment plans. Apple has now brought that back to the forefront with their iPay. And that's going to be a huge game changer when it comes to mobile payments because they are invested heavily in it and they're going to move the market. Attacks on other services, like I said, banks, credit cards, etc. Developers are going to continue pushing the technology probably beyond what it needs to be, and we'll catch up with the security as we always do. And then Google's changing the Android platform. I know they're changing the development code. Whether it's more secure or not, I don't know. I haven't done enough research in it. And that kind of concludes it. So now I'll open the floor to any questions. I know you had a question right off the top. Yes. If you want to run 2 emulators on the same computer, you can. It's a little more difficult because what actually the emulator does is it actually creates like a netcat listener on it and pushes. That's how it gets from point A to point B. You can do it. You have to go through you have to go through like that ADB bridge, and you have to do some TCP forwarding, and then you can actually get it between the two of them. In the book that I wrote, I actually explained how you can do SMS messaging between 2 emulators. So it does work. You had a question? Yes. Back to all the resources. Whoops, not that way. Oh, there we go. That good? Okay. Anybody else have any questions? Shoot.
Android's kind of moving away from open source. Do you think that's good or bad for security?
It's just like open source. I think it's both. And I'll qualify that. Open source is really good because, in theory, everybody's supposed to analyze it and be able to say where the flaws are and those type of things, and should get fixed relatively quickly, right? We've seen in open source that doesn't always occur because as something gets adopted under open source, there's a lot of players. The more players you get involved, the more fractured and things can come along. Think of like the Apache project, for instance. How many Apache projects are there underneath it? And they're all, because they keep splintering off going, I want to do this, or I want an engine to do that, and it becomes a big bureaucracy. Closed source could potentially make it a little bit more cleaner as far as running, but I don't know if it would necessarily make it that much more secure, only because people poke Windows all the time, and it's closed source. I mean, I don't necessarily see an inherent value in doing that, unless you're going to go to the point where you're going to analyze every app that gets out in the App Store. That's the only thing I can say specifically. You had a question? Yes. Okay. You had a question? Yeah. Yeah, that's actually a VMware virtual machine. I'm going to release it. Actually, did everybody get this piece? If you go out to, whoops, wait a minute. Sorry, that one. If you go out to Spectre Labs tonight, you'll see a download folder, and I'll put a link out there, or I'll get it to you in one form or another. It's a rather large zip file. This is beta, so I want to qualify that. We have all of our tools on there, and it does work. It works in our environment. We haven't extensively tested it everywhere yet, and we want to make sure that it works, but I thought I'd let people see it, kick the tires. If you have a problem with it, I'll try to fix it. I am the person who actually tries to fix that because it's what we put together, myself and another colleague. Any other questions? Yep, somebody else wants resources. Oops, and I keep going the wrong way. Oops. Resources. Okay, anybody else have any questions? Sweet. I hope you at least got something out of different ways you can. This is kind of what I do as part of my day-to-day process for analyzing mobile malware. This is kind of the setup that I have that I actually do, and I do it pretty frequently. So you got a pretty good taste of what it is like for us to do APK analysis on a day-to-day basis in an actual Malcode shop where they're asking for it. I hope you enjoyed it. If you have any questions, feel free to come up here and give me a shout, or I'll give you a card, and we can chat offline. Appreciate it.